Alright, so they left breadcrumbs in the code. 28 references scattered across 114 files. And now we know what's coming. DeepSeek just accidentally revealed their next weapon. It's called Model 1. And based on what developers found buried in their GitHub repository, this thing is about to rewrite the rules of AI again. Here's why you should care. Exactly 1 year ago, a small Chinese AI lab released a model called DeepSeek R1. Within 24 hours, Nvidia lost $593 billion in market value, the single biggest stock crash in Wall Street history. Why? Because DeepSeek proved you don't need billions of dollars and endless GPU farms to compete with OpenAI and Google. They built something just as powerful for under $5 million. And now they're back, with something potentially bigger. But here's what nobody noticed. This wasn't supposed to happen. DeepSeek didn't announce Model 1. They didn't write a press release. They simply updated some code on January 20th, 2026. And eagle-eyed developers started digging. What they found changes everything. The leak happened in something called FlashMLA, DeepSeek's attention mechanism for processing AI. Inside the updated code, developers discovered 28 references to an identifier called Model 1, not an update to their existing v3.2 system. A completely separate branch. A new architecture running in parallel. This is where things get interesting. The code shows fundamental changes. Model 1 uses a different memory layout than anything DeepSeek has built before. It handles data differently. It processes information differently. And here's the kicker. It's optimized for Nvidia's Blackwell architecture. Those are the B200 GPUs that don't even officially exist yet. DeepSeek is building for hardware that isn't commercially available. Think about what that means. But the real breakthrough isn't the chips. It's something they're calling Engram. Remember how your brain works? You don't recalculate that Paris is the capital of France every single time someone asks. You just know it. It's stored. It's instant. Current AI models don't work that way. Every time they need a fact, they have to reason through it. They waste computational power recreating knowledge they've seen a million times before. Engram fixes this. It separates memory from reasoning. Here's the genius part. Instead of forcing the AI to use expensive neural networks to remember basic facts, Engram creates a lookup system, like a massive instant access database. When the model needs to recall something simple, it doesn't think, it looks it up instantly, using something called O1 complexity, which in computer science means constant time retrieval regardless of how much data you have. And this changes everything about how AI works. Traditional models mix two completely different jobs into one system: static memory and dynamic reasoning. It's like using a supercomputer to add 2 plus 2, wildly inefficient. Engram splits them apart. Facts go into fast memory lookups. Complex reasoning uses the actual computational power. The results are insane. In testing, models with Engram jumped from 84% accuracy to 97% on long context tasks. That's not a small improvement. That's the difference between basically useless and actually reliable. And here's where it gets scary good for developers. Engram can handle over 1 million tokens of context. That's not a typo. 1 million. That means you could feed it an entire codebase, not snippets, not files, the whole thing, every function, every dependency, every connection. And it would understand all of it. Internal benchmarks claim V4 is beating Claude and GPT-4 on coding tasks, specifically repository-level coding. The kind where you need to understand how changing one file affects 50 others. The kind that currently makes AI assistants hallucinate and crash. But there's more. DeepSeek published another paper in early January about something called MHC, Manifold Constrained Hyperconnections. It sounds academic, but what it actually does is wild. It makes neural networks learn faster by letting information flow across layers more efficiently, like upgrading from dial-up to fiber optic. These aren't separate features. They're working together. Engram for memory, MHC for reasoning, MOE architecture for efficiency, all running on optimized kernels designed for next-generation hardware. Now here's what makes this truly disruptive. DeepSeek allocated about 20 to 25% of the model's capacity to Engram memory. The rest goes to computational experts. They found a U-shaped scaling law that shows exactly how to balance static memory against dynamic computation. Too much memory, performance drops. Too little, same problem. They found the sweet spot. And remember, this entire system is being designed to run on consumer hardware, dual RTX 4090s, or a single 5090. You could potentially run a GPT-5 class model on hardware that fits under your desk. The timing is perfect, or perfectly calculated. DeepSeek is targeting a mid-February release, February 17th, Lunar New Year, exactly 1 year after R1 destroyed the stock market. They're not hiding the pattern, they're advertising it, and the market knows what's coming. Last time, they triggered a $1 trillion tech stock sell-off. This time, they've been quietly building something more sophisticated, more targeted, specifically designed to dominate the one area where Western AI companies still claim superiority: coding. If V4 delivers on these internal benchmarks, it's targeting Claude Opus 4.5's 80.9% score on SWE Bench Verified. That's the gold standard for AI coding assistance. Real GitHub issues, real bug fixes, no multiple choice. Either the code works or it doesn't. Claude currently owns that record. DeepSeek is coming for it, and they're doing it with a model that costs a fraction of the price to run. DeepSeek R1 was 20 to 50 times cheaper to use than OpenAI's O1. The geopolitical implications are staggering. Western chip export controls were supposed to slow down Chinese AI development. DeepSeek keeps proving those controls don't work. They trained R1 on restricted H800 chips. Now they're building V4 with memory systems that reduce GPU dependence entirely. Every time the West restricts hardware access, DeepSeek responds with better software, and it's all going open source. Unlike OpenAI and Anthropic, which have moved toward closed systems and billion-dollar valuations, DeepSeek keeps releasing everything. Code, weights, research papers. They're not building a business, they're building an ecosystem, and every release makes their technology harder to ignore. The development community is already preparing. Forums are buzzing with setup guides for Ollama and VLLM instances. Developers are planning their migration strategies. Some are waiting to see the benchmarks. Others are ready to switch the day V4 drops. Here's what nobody's saying out loud. If V4 actually beats Claude and GPT on coding while running locally on consumer hardware, the entire AI API business model collapses. Why pay per token when you can run the same quality model on your own machine? Why send proprietary code to external servers when you have equivalent capability locally? This wasn't an accident. This was a marketing campaign disguised as a code leak. The AI community is treating Model 1 like an Easter egg hunt. Every commit gets analyzed, every file change documented. Developers are reverse engineering the architecture from code comments and variable names. It's like watching people reconstruct a puzzle from shadows. And DeepSeek hasn't said a word. No official confirmation, no press releases, just silence, which makes the hype grow stronger. Here's what we're watching for when V4 launches. First, the actual SWE bench score. Does it beat 80.9% or fall short? Second, long context performance. Can it really handle million token code bases without degrading? Third, local deployment reality. Do those consumer hardware claims hold up under real-world testing? Fourth, and maybe most important, integration. Does it work with Cursor, VS Code, all the tools developers actually use? Or is it powerful but isolated? And Model 1 suggests they're accelerating. February 17th. Mark your calendar. Whether you're a developer, an investor, or just someone who cares about where AI is heading, this release matters. Because if the last year taught us anything, it's that DeepSeek doesn't bluff. When they say they built something, they built it. The code is real. The papers are published. The architecture is documented. All that's left is the launch. And based on everything we've seen, it's going to be explosive. Alright, that's it for today. If you want more AI breakthroughs like this, subscribe and drop a like. Thanks for watching, and I'll catch you in the next one.